All right, hello everyone. So let's talk about the experiment 14, which is the final project. And remember, this will be a one person project. Uh, First of all, remember the pre-lab for this project will be not grading, but you want to still submit for some feedback. Okay, so I want to make sure everyone is on the right track before you start to build the circuit on the breadboard. And one suggestion is that you can try to run the circuit on the IoT space for pre-lab, so you can check the simulation result first. Okay, and then the report will be due at May 1st, end of the day. Okay, so basically we will do the final project this week and the next week. And then you have one more week to finish the final project. Yes, so this week and next week. And this is the day for the final project report due. And the format of the project, final project report will be similar with what you've done in the lab file. Okay, so there are a couple documents you want to read through before you start doing the project. The first thing will be the topology on the brightspace. So basically, it's this document. So I will talk about this later. And then there's a video on the course website. So please make sure you watch through. Watch this video before you start doing the experiment. And then let's start talk about the project. So basically, for this final project, you will do a audio equalizer. So this circuit is basically working for the speaker. Okay, so and the circuit will be looks like this. Okay, so first of all, there is input audio, and which maybe is the music signal, and it will go to the equalizer, and then you have a volume control, and also before the speaker, there is a power amplifier, and there's a high pass filter and a low pass filter, which will divide the music signal into two different frequency range. Okay, and basically this this circuit is divided by two parts. Okay, so this part and this part. And you can simply find this part in previous lab. I believe it's in the lab 10. Okay, experiment 10. The last task is about this part. And for this final project, the important part is the equalizer part. Okay, so this will be the part very important. And and this part, the crossover circuit part, which you done in experiment 10, will be the actual credit for you. Okay, if you check the question, this will be the actual credit. All right, and let's go to here. So this will be the part for the equalizer. Okay, so basically this part will be specifically something like this. Okay, so let's talk about this two document together. Okay, so basically this part, the circuit of this part will be looks like this. Okay, so and also this circuit is as a reference. you don't have to build exactly circuit like this, but this document will give you a general idea of the design. Okay, so as I mentioned, the equalizer or this circuit will be working for a speaker. Okay, so let's say this input signal will be a music signal, and this music signal will divide by 3 different parts by their frequency range. Okay, so for example, the lower frequency will go this path, and the medium frequency will go this path, and the higher frequency will go this path. And then these 3 frequency range will combine together to one path after this. And simply you can use the filter to divide the frequency. So this 3 frequency will be low pass filter, band pass filter, and the high pass filter. So will be corresponding to this 3 circuit. Okay, so this is a low pass filter, band pass filter, and the high pass filter. And after the filter, there is a volume control for each different frequency. Okay, so for example, you want your music has a very strong bass, but less volume on the high frequency part. Then you can try to turn on the signal for this path, and maybe you can turn off the signal for higher frequency. So then you can feel your music have a very strong bass. So how you can do that is you can use a volume control. Okay, so which you can simply use an amplifier to control each volume. And of course, to control the volume, you will use a potentiometer. Okay, so the RV1, RV2, and RV3 will be the potentiometer. So if you want to turn off or turn on, or you can adjust the value by tuning the potentiometer. Okay, so basically this is the circuit for the equalizer part. And and I think you already play with the low pass filter and high pass filter, and you are like kind of new with band pass filter. So this kind of filter is actually very similar with this too, and it's just a combination of high pass filter and the low pass filter. So you can see is something like this, okay? Because this is the magnitude response of the as a low pass filter, and this is a magnitude response for high pass filter, and this is the band pass filter. As you can see, this is just a combination of these 2 plots together. You will get something like this. So band pass filter, which means you just want the frequency at some frequency range, band range. All right, so that's this part. And when you calculate the frequency or the value for each component, you will use the cutoff frequency equation. So one thing you need to pay attention is when you build these 2 circuits together, so this low pass filter and this amplifier together, these 2 circuits may affect each other because of the loading issue. For example, this R1 value is very similar with the value for R2. This will cause some loading issue. Okay, so there are 2 solutions to solve this problem. One way you can do is you want to make sure this R2 is much greater, the value for R2 is much greater than R1. Okay, another way you can solve this is you can put a buffer between these two circuits. So the buffer will be looks like this. Okay, so this is a buffer, and I believe you already learned this in previous lab. I think in lab 8. So this is a buffer you already built before. So why you need a buffer is simply because a buffer have a very high input impedance and a very low output impedance. So you can kind of separate these two circuits and let them don't affect each other. Okay, so similarly for here and here, you do need a buffer if your resistor value too close together. All right. And and then this part is the summing amplifier, which you can see I think if you check the lab menu on lab 8, there is a section talk about the summing amplifier. So which help you to, after the music signal divide by 3 parts, this summing amplifier will combine the signal back to one pass. Okay. So let's check the requirement for this circuit. Okay, so okay, first of all, the cutoff frequency. Okay, so as I mentioned, you will use filter, and the filter for the cutoff frequency for these 3 filter will be here. So for the base filter, which is a low pass filter, you want to the cutoff frequency at 320, and the high pass filter, you want to the cutoff frequency at 3.2 kHz. And this is the range for the bandpass filter. All right, then next, after you calculate the value for filter, you also want to calculate the component value for amplifier. Okay, so there are a couple requirements for amplifier. So when you tune the audio equalizer knob to minimal setting, so which means you want to tune all those potentiometer to minimal resistance of those, and then when you check the amplitude after the summing amplifier, this all the amplitude of this signal should be smaller than 15 million VRMS. Okay, and you want to make sure you check this 3 range. So basically, what you will say is after you build this circuit, the signal will be something like this. Okay, so first of all, the low pass filter, the signal is something like this. So this is a magnitude response when you use the network. Okay, so the network from the AD2. Okay, so then this is a high pass filter, so the magnitude response will be something like this. And then this is a band pass filter, the magnitude response will be something like this. Okay, so so you want to check the frequency at 200, 2K, and 10K. So maybe 200, maybe it's something around here, and the 2K maybe something around here, and this will be the 10K. Okay, 10K, 2K, and 200. All right. So ideally, after you make everything work and you measure the signal or the magnitude response at here, you will get some plot like a flat line because you already use the summing amplifier combine these three filters signal, so you will see the flat line. And for this requirement, when you tune all the potentiometer to minimal setting, this amplitude will be less than 15 million VRMS. And then the next requirement is when you tune out all the knobs to maximum, so which you tune those things to maximum, you will see the amplitude at this output around 100 million VRMS. Okay, and by the way, this output is based on the input is 1 VPP, so 1 volt peak to peak, which is 0.5 amplitude. Okay, so after you tune these these 4 knobs to maximum, you want to make sure you check your output. It looks like a straight line, and the amplitude should be 100 million VRMS. Sorry, it's a bad handwriting. So make sure when you take a screenshot, you mark this 3 point. The value should be around this value. All right, and then the last requirement is you want to check the ripple of output, the Vamp, is less than 15 million VRMS. Okay, so what's the meaning of that? Ideally, the output at here will be a straight line when you're checking the magnitude response from network. But the real circuit will maybe have some fluctuation. Okay, so maybe your magnitude response looks like this. And then you want to check this might be the maximum point and this may be the minimum point. And you want to make sure the difference of these 2 points is less than 15 million VRMS. Okay. Right, so I think that's all the requirement for the circuit. And then how you can calculate the value to satisfy the requirement, especially for this one. So let's say second. So let's say this. So this will be your 1 second. So this will be input, and the input at here will be 1 volt VPP. Okay, and then how the signal will go through is go this way, and this way, and this way, and then combine together. And you want to satisfy the 100 million VRMS when all the potentiometer acts as maximum. So how you can calculate this is you can calculate like 1 by 1. Okay, so for example, let's calculate the low pass filter one part, which is the frequency at 200 hertz. Okay, so that's for the low pass filter. Okay, so then let's take an example. So for example, the gain of this amplifier is VA. I mean, maybe not VA, GA. So that's the gain for this amplifier. And then the gain for this summing amplifier may be Gx. So what's the amplitude, the wave amp at 200 hertz? Okay, so it will be equal to wave amp is equal to wave in, so which is this thing, times the gain of this first amplifier, so will be GA, and the gain of the summing amplifier will be GX. So that's how you can calculate the maximum wave amp at 200 hertz. And then you also want to check the gain for 2K hertz, and that depends on this amplifier and this amplifier. But the calculation process will be similar. So it's just simply the total gain is equal to this gain, this amplifier's gain times this one for each different frequency. All right, so that's how you can get the value for those resistors, and you already calculate the value when you use the when you decide the cutoff frequency. All right. Okay, let's see. Okay, let's see what else. All right, so one thing I mentioned in here is you want to measure the subsystem first. So as you know, this circuit diagram is a combination of different small circuit, like a filter, amplifier, and the summing amplifier. So what you want to do is you want to build the subsystem first, or you want to build each individual circuit first. So first of all, maybe you want to build a low pass filter, and then you measure the magnitude response for this single low pass filter. Make sure the cutoff frequency is what you want. Okay, then maybe you can measure the band pass filter and the high pass filter. Make sure all the filters works as you want. And then what we can do is maybe you can measure this amplifier. Okay, make sure this amplifier works as you expect. And then next, you want to combine these two circuits together. Okay, make sure when these two circuits combine together, they works as you expect. Then you verify these two together, these together, these two together. After you verify each subsystem, then you can verify this whole thing together. So this is the equalizer part. And even that is not done yet. If you want the extra credit, so that part is basically this part. And then if you want the extra credit, you also want to verify this part individually, and then combine these two things together. That will be the whole system. Okay, and remember when you measure each individual part. Okay, so for example, you measure this low pass filter, and you by using the network, and you measure the magnitude response. When it works, you want to make sure you take a screenshot of this individual part. Okay, so even at the end of the day, you cannot make this whole system work. At least you make the subsystem work, and you will still get partial credit for your lab report. But hopefully you can make the system work. All right, so I will not going to talk too much about the accurate credit part. Just remember you can find the circuit in the Lab14 task 4. And there are a couple equations for for that part. All right, I think that's all for today's task, for this final project. And I think all the components you need you can find in the your lab kit. But if you, for example, if you find out your amplifier is broken, you can always go to the EE shop, so EE162 to get a new op amp. All right, I think that's all about today's task or the final project. And you will remember you have 2 weeks finish it, but you don't want to do everything at the very last 2 days. Okay, so try to start early and let us to check the pre-lab before you start to build the system. All right. Okay, so just let me know if you have any question.